Yo Minasama, let's start lecture 7 summary. So, in this lecture, we'll talk about V-Stone Bridge. So, what is V-Stone Bridge and how to recognize it? Basically, its general structure would be here we have four terminals connected, where two of them are connected with two resistors and another two are connected with three resistors. So, Uh, so two of the terminals are connected with two resistors and another two are connected with three resistors. And here we name R1, R2, R3, R4. Here this into this R1 into R4 should be R2 into R3. Are completely disconnected resistors multiplication should be equal to other two of the resistors which are completely not having any common points. Those two resistors product will be equal, or we can say common ones, division should also give us the same results. R1 by R3 equals to R2 by R4, or R1 by R2 equals to R2 R3 by R4. Now an example, you can find this is 3 6 root 19 5 and 10 ohms. So 6 5s are 30 and 6 3 1s are 30. So we can cancel this out. So basically it would be 15 into 18 by 15 plus 18, 33, not 33. It would be 15 into 9, 6, 7, 8, 9, and this would be 4. R equivalent would be that. Now then, let's move on to second example. That would be, what if we need to find out the resistance responsible for such that it becomes a V-Stone bridge. This is 50R by 50 plus R, and here it is 50, and here it is 200, and here it is 100. And let this be R. We should make it into a V-Stone bridge. So 550 into 100 equals to 200 into 50 R by 50 plus R. 50 50 cancel, 100 cancel. 50 plus R should be equal to 2R, so R equals to 50 ohms. In such cases, if R equals to 50, then we can have it as a V-Stone bridge. Now, example 3, where we are given not a not an appealing circuit, but we have to find out whether it creates a V-Stone bridge. So here, what would the resistance be? Here, R equivalent is given as R. Let's see, there's a bit question here. Here it is R, 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 R. Yes, this is A, B, C, D. Yeah, C and D. And this is V. Let's find out the equivalent resistance. And then the question is about finding current in each wire. Uh, Current in each wire. Yeah. So first we'll find equivalent resistance. But before that, we'll remake this. D up, C down. Between C and D, there's another resistor, R, 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 and R. It creates a V-stone bridge, R square equals to R square, so we can neglect this one. And current through that wire is 0. Now, the total current would be R, this would be 2R, 2R, so total equivalent resistance would be R, and I equals to V by R. So here V by R, here also V by R. And because if you see here, both resistance are R, so by symmetry we can say that the current passing through it would be I by 2 or V by R, V by 2R. Yep, that is right. V by 2R. And the same current, and because no current would flow through this, the same V by 2R would flow from here. And also it would come from here and V by 2R. And here also V by 2R. It would join and form V by R. Then the next example. Oh, so next we have another concept that would be equivalent resistance and symmetric current, symmetric circuit. So basically, in a symmetric circuit where it is somewhat like this, we can say, uh, if in perspective of the current, if it is, if we can cut it into half like this, and above and below are the same, then we can flip it over. And as their common points would all be similar, they'll be in parallel. So that would be so this is R, 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 and R. So as they are parallel and here it is common, here it is common, here it is common, so it is a parallel one. So this would be R, R, this would be R by 2, R by 2, R by 2, this is R by 2, R and R. Now it just forms a V-stone bridge. So R into R by 2, R into R by 2 is same. So we can ignore this middle wire here. So that would give us 2R and R to be uh, parallel to each other. So 1 by R plus 1 by 2R would just be 2R by 3 are equivalent. Ain't that right? 2R by 3, yes. Now, we can solve the same question, I guess, with a little bit of trick. This was the trick, but there are other methods that we can use. So for example, the trick that we had earlier talked about. So because current will go here and here, we'll see three different similar paths. It would go equally on all of them. And here, if we see, the same should come out. So here also R. So by symmetry, if it is going like this, then they should connect like this. So we can ignore these. So basically, now what we have is 2R, 2R, and 2R in parallel. So that would be 2 by 3R. 2R, 2R, and 2R in parallel. So yeah, 2 by 3R. Same as last time. Then, uh, similarly, you can find out using other methods. That was another method. We can also use KVL and KCL, but that's for another time. Now, what if it is not symmetric about that line? If it is not symmetric about this line, what can we do then? This is R to R, R to R, R to R, R and R. Yeah. So we can't cut it like this. So the current going like this can't come like this. So like we can't tell I is going and I will enter. So what we can do is it is still symmetric by the way like this. It is still symmetric like this. So we can flip it over and write it again and do. But what we are interested here is to learn another method that is applying KVL and KCL. So we can use that here. So what we are trying to do is, so again, here I1 current goes, here also I1 is going, then because these parts would be oddly similar, but not so much here. So this would be, if I is coming, I minus 2I1. So that would be I minus 2I1. Now, if it goes like this, we can say potential here should be X, and here also by symmetry it would be X, and here it would be Y, if that, because its potential would be different. Now, if we apply, yeah, we can apply KCL here, can't we? Yes, we can. That would be here, it is given to be V volt, 100 volts, 100 volts. So this would be 100 here, 0 here. Now it would be much easier. So now we can apply KCL here, KCL, yeah. So that would be X minus 100 by R plus X minus 0 by 2r plus x minus y by r equals to 0. That is our first equation. Let's write here. Now, if we apply KVL here, KCL here, that would be y minus 100 by r plus y by r minus 0 by r and 2 times y minus x by r. This would be 1 minus 0 by 2. Now, we need to solve for x and y, so let's eliminate r first. That would be if so like this, that would be multiplied by 0, that resistance also becomes 0. So that would be y plus 2y minus 200 plus y plus 4y minus 4x equal to 0. 6y, 6, not 6, 7y minus 4x minus 200 equal to 200. Now, if we do the same here, 2 times of this, 2 times of this, r goes out. So this would be 2x minus 200 plus x plus 2x minus 2y equal to 0. So that would be 2, 5, 5x minus 2y equal to 200. So this is 5x minus 2y equals to 200. Now, uh, we multiply this with um, if we plus and minus this, that would also be fine, but it would be lengthy. So 7 is a 14y minus 8x equals to 400, and this into 7, 7 35x minus 14y equals to 1400. So if we add, these get cancelled. 10 minus 8, 2, so 27x equal to 28. X equals to 2800 by 27, isn't it? I think we have made a mistake while writing the KCL. So x minus 100 would be plus, obviously, but while writing this would be 0. So we can write it as x minus y by 2r, then x minus 0 by 2r. I can see what the problem is here. Nope, we are absolutely right here. This would be 1800 though. Now, if we substitute it somewhere, we can simplify it using 3 also. 18, and that would be 200 by 3. So x is equal to 200 by 3. If we substitute that here, 2y equals to 5x minus 200. So 1000, right? 1000 by 3 minus 200. So 600 minus 1400 by 3. 2y equals to that 200 by 3. So x and y both are 200 by 3. So if potential are same, then no current would flow through this one or this one. So we can ignore them. Now, basically we have this. So 3R, 3R and 3R. So that would be 3 by 3R. So R equivalent equals to 3 by 3R is equals to R. Yep, we are right. Now let's get to business and the next question. Now, uh, we have another question. We can solve this too by different methods. One of them would be this one seems a bit complex, but it is not. In this, every one of them is R, and R. So what we're doing here is we can either flip it over. So we'll have something like this. As they're parallel and we can add them with parallel ones. We'll have R remain R. Here it would be R by 2. And this would be R by 2, I guess. Yes, R by 2. And this would be R by 2. And this would be R by 2. And this would be R by 2. But if we see through symmetry, current which goes here is joining here. So it won't take any deviations. So it won't go like this or like this. So no current will be passing like this. But we can assume it would be going like this. So if we join like this also, there's no problem. So this would be R plus R by 2. That would be 1 by R plus 2 by R. Yeah, so R by 3. R by 2 plus R by 3. So R plus R by 3, R by 3, R plus R by 3. So that would be 4R by 3 and 4R by 3 and 2R are in parallel. So 4R by 3. So 3R by 4 and 2R, right? So R, there would be 4R by 5. So equivalent resistance would be 4R by 5. But what if we took a different approach? What if instead of this, we went to assuming current here, current going inside, coming outside would be same. So if we assume potential here to be 0, here if we go up through this, it would increase by x, and increase by x. So if that happens, it's safe to assume that we assume a battery of 100 volts is here. So if we assume like that, we can say here 100. Coming up, its x would be increased. So going down, x would be decreased. So 100 minus x. This is the potential here. Here 100 minus x. And here also, if we see, it would be 100 minus x. So if we say 100 minus x equals to x, So X equals to 50 volts. So we got our answer. X is equals to 50. So this would be 50 volts. This would be 50 volts. And this would be 50 volts. And this also 50. Mid one is also 50. Now, as all the potentials, nope, we did a great big mistake. This is an error because if we see if all of them are equal, then what value would resistance hold? So that is not the case. Only here it would be 50 because only at this case it is 100 minus x equals to x, something like that. So now if we see, it should be x, it should be 100 minus x. So we'll just apply KCL here. Like we can apply 100 x minus 0. We'll apply KCL here. So that would be x minus 0 by r plus x minus 50 by r plus x minus 100 minus x by r equal to 0. So that's the case. X, 2x. So 2, 3, 4. 4x by r plus minus 100. So minus 150 by r. This would go. So x equals to 150 by 4. So 70 by 2 volts. So x is 70 by 2 volts. So then this is 70 by 2, 75 by 2 volts. Then 100 minus 75 by 2 would be 200 minus 75 by 2. That would be 125 by 2. Is that right and right? Yep. Is it 125 by 2? Let's see. 100 minus 100 minus 25. 175. Is it? Just we again apply KCL here. So that would be here I would exit, right? So potential difference across this divided by R and R and R. So 75 by 2 by R plus 50 minus 0 plus this will also be x. So 75 by 2. 75 by 2, 75 by 2 would be 75. So that would be 125 by R. This is I. So R equivalent equals to V by R. Here V is 100 volts. 100 by V by I. So 100 by 125 into R. So that is that 125 by 100 by 125 into R. Next we have for what if the circuit is a bit big, such as a cube. Here each wire before and after the junction is having the resistance of R. So here if we connect A, let's name them. This would be A, B, C, D, E, F, G, and H. So A is joined with D, and there's a potential carrying device which is battery of 100 volts. Now we should find, oh my god, that's not right. It's another question. We join A and H. We need to find equivalent resistance between A and H. We need to find equivalent resistance between A and H. And here 100-volt resistor is there. So what we do is there are two methods here. One would be the assuming X and going about that, or we can say common potentials here A, and current is being distributed here and it is being collected here. So current would be divided by as I by 3, I by 3, and I by 3. So resistance here would be X, X, X. And as we needed to join here, was an error in the question. So it was V volts. So if we assume here, here also while joining, the current would come as I by 3, I by 3, and I by 3. It would spread as I by 3 and connect as I by 3. So if we say it to be 0, then if we crossing this wire, we'll get some X potential. Here also X, here also X. And going from down to up, we are getting X potential. Then coming from V volt and going down would be V minus X. Here this is V minus X. And this would also be V minus X. Now we'll apply KCL somewhere here. If we consider it to be 100 volts, 100, 100, we are covering two of such questions. So 100 minus X, then we'll apply somewhere here. So if we apply here, X minus 0 by R plus 100 minus X minus 100 minus X is 2X minus 100 by R, plus we have same. So 2X minus 100 by R equal to 0. Or we could have just collected the common points. The common potential is for 1, 2, and 3. So we'll write FBD. FBD will be the same here. From A point, they all connect to this is A to FBD. Then in FBD are connected to EGH, E, G, and C. Is that right? This one is over. This one is over. This one is over. This, and this. So FPD is over. E, G. This is they have X potential difference. This is 0. This is X. 100 minus X. Sorry. This is V. This is 100 minus X. We say let's arise from H. So from H we have other points here too. It does get quite a bit confusing, but can work. So these three have same potential. We have written them together, and these three will have the same ECG. ECG and H is here. So from ECG, it would be parallel from each of them. Parallel. It would cut like this. H, H. Yeah, it's parallel. We have the same potential. Now between these all, again we have the common points. These and these. F and D, F and D, F and D, E and D, E and D, E and D is over. And here it is B and G. Have we covered them all? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 7 and 8. Here and here we have covered them. Here we have covered F and G. F and G. F and G is also covered. F and E. Oh, we have other connections too. I had just left F and G, and then this and this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges, 12 resistors. So this would be all are R. So 1, 2, 3, 4, 5, 6, R by 6. 1, 2, 3, R by 3. This is also R by 3. So 2R by 6, 2R by 6, 2, 4, 5, 5R by 6. That is 5R by 6. Yes. Now what if we had to do it using KCL KVL? That would be, we'll just use one of the sides, one of them, and apply KCL. We can find X, and then from that we can just where it is joining, we can say potential difference and divide it by R. So X minus 0 by R plus X 2X minus 100, 100, 2X minus 100 by R plus, again 2 times equal to 0. This would be 455x by R minus 200 by R equal to 0. R now cancel. X equals to 200 by 5. 5 4s are 20, 40. So X equals to 40 volts. Now we'll apply here. So X, X, X. So 3 times X minus 0 by R equals to I. So 40 gives 12 by R equals to I. So I equals to 12 by R. Now let's take another example. I want to get this too long. So now we have same setup, but using symmetry we can pretty much cancel many of them. A B C D E F G H. A B C D E F G H. But if A and C are connected, then I would do like this. I incoming. This is V. I by 3, I by 3, I by 3. So, funda here is, if it goes like this, here I is going and I is coming. So, pretty much here, no potential difference. So, we can, so no current will follow here. So, we can cancel that out. So, now basically, these are in parallel, these are in parallel. Then these would be in a parallel again. So these two are parallel, R, and R. So that would be 2R, 2R, 2R and 2R. That would be R, R. So 3R, 3R, and here also R, and R. This would be parallel. R, 2R, 2R, R. So R, here R, right? This and this R, and so that would be 3, 3R by 4. That is 3R by 4. Yeah. R equivalent would be 3R by 4. You can write the old method, but would be too lengthy. You wouldn't do that, right? Now, last example here, the same one. I shouldn't have rubbed it off. A, B, C, D, E, F, G, and H. A and C are connected. Yeah, A and C are connected. Now, if we see properly, we can like smush it inside, then it would basically be A, B, C, D, A and C, A, B, C, D, and here is A and F, D and E, and E, C and H, and B and G. It will form something like this. Now we can just, with symmetry, flip it over. These are all R, and with symmetry, this would be R by 2. This is R by 2. This would be R by 2. This is R by 2. R, we can say R. And this would be R by 2, R by 2. Now this is 3R, I guess. Nope, I'm very wrong. This is R by 2. This would be 3R by 2 and 3R by 2. Yes, R and R by 2 would be 3R by 2 and 3R by 2. Now 3R by 2 into R by 2, 3R by 2 into R by 2 is equal, so we can ignore the R by 2. So now it is 3R by R, 3R and R. So that would be, what would it be? 4R by 3R by 4. 3R by 4. Yep, that's it. Thank you.